This is a reminder Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please don't share personal information during the class for your own security reasons. Here we go. We are in the February 5th attendance ticket. Give me those green checks. I already have 9 of them, so thank you, Tony, Danny, Dylan, Isaiah. You guys are awesome getting that up there. Thank you. Now I'm seeing more green checks. Thank you all for getting those done. Get that open, ready to go. You do have more than just the last word today, so we do have some questions to go over today. So making sure you got that ready to go for our first question that'll be coming up in a little bit. Awesome. Okay, so we are on day 6 of quarter number 3. Today is Tuesday of week 2. Today we are talking about motion and acceleration. We are starting our second unit. Guys, it goes by so quickly. We actually have about 1 unit. No worries, you totally understand. Just make sure you save. Okay. So sorry, what was I saying? Okay, so the quarter goes by so quickly that pretty much every week we have a entirely new unit because there are 10 units in the course and there are only 10 weeks in the course. So it does seem to go by very, very quickly and you feel like we're flying through it, hopefully. I think it's better if you feel like it's flying. But yeah, so we're starting our new unit. We're going to talk about motion and Newton's laws of motion. So it should be a good unit. Let's jump into it. So some quick announcements here. Remember, if you only have a few errors on the 1C lab, smiley faces if you've done the 1C lab, you felt good about it, or you at least got it submitted, smiley faces, awesome, seeing those pop up, perfect. So if you see your grade and you're not super happy with that grade, you can take a look at what you got right and wrong on it. All you need to do is go to the progress tab, click on the quizzes option on the left. Yes, Andres, let me know what's going on. And then scroll down, you'll find the 1C lab, click on details, and then you can actually see your attempt and you can see every grade that you got on each question. So if you see that you only have a couple mistakes, definitely just email me and you can fix those mistakes through email. You don't have to submit a completely new attempt. If you're not sure exactly what went wrong, don't worry. Again, just email me and I am happy to help you with that. Again, here's my email up here. Okay. Now keep in mind that we do have week 2 extra credit, so you can get 1% extra credit. So Andres, you should see 10 points then in your grade for the Unit 1 review. Okay, if it's not showing that you have 10 points, go ahead and email me and let me know that that's a mistake. Sometimes Kahoot doesn't always do perfect reports when I pull it, so it just might have missed your name. So that being said, just email me if you don't see your 10 points for the Unit 1 review. But yes, if you weren't here yesterday for the Kahoot, everyone, make sure that you do the Unit 1 review assignment, the alternative assignment. But again, Andres, just double check it. Okay, if you were in the report, it definitely should show that. Okay, it definitely should give you 10 points. Okay, awesome. But again, it might have made a mistake, so no worries, email me and I will fix it for you. All right, looking good. So week 2, you can get extra credit. Remember, you get up to 1% extra credit per week. There are 10 weeks, so in total, how much extra credit can we get? Tell me in the chat box. How much extra credit can we get? If we get 1% per week, 10 weeks total, how much extra credit does that add up to? Israel knows what 1 times 10 is. Good. Get your answers in the chat box. Again, 1% each week. There are 10 weeks. What total percentage of extra credit could you get? Awesome. Perfect. Yes. Yes, I see answers coming in here. Good. Yes, you can get up to 10% extra credit. That is the difference between a B and an A C and a B, so on and so forth. So that 10% can be super helpful. It's super easy. If you've been to one of the sessions before, it's really not bad at all. It takes 5 to 10 minutes. All you need to do is you'll fill out a support contract, just letting me know how you're doing in the class so far, your goals for the rest of the week, and then you'll just sign it with your initials, submit it, and I will double check to make sure it looks good, and then you're all set for it. So it's super easy, guys. So we've actually already done the Tuesday one, so you don't have any more support today. But even if you miss today's, you can still get your extra credit. Just attend tomorrow at 2:30. Sorry, at 2 o'clock. You guys are last names N through Z. Attend tomorrow either at 2 o'clock or Thursday at 10 a.m. So those are your last 2 chances for the week to extra credit. Now, super important. How many of you have heard of Star 360? In the chat box, say yes, no. Have we heard of Star 360? We know what that is. It's the reading and math assessments. Yes, now you do get a grade for Star 360 in every single class. It actually counts as 10% in every class, whether it's history, science, math, English, tech, so on and so forth, okay? So even though Star 360 is technically only a math and reading assessment, you still get a grade in every class. So it's a huge grade across the board, okay? It is 10% of your grade. And it is being zeroed out today in every class. So if you haven't completed it yet, you will see a 0 go in at 4 p.m. And sorry. Yeah, so definitely, Andres, get that done. The report doesn't actually come out until tomorrow, so you won't actually see the new grades until tomorrow morning. So even if you see the 0 go in at 4 o'clock and you're like, but I did it, don't freak out. Again, it's just because the report doesn't come out until the next day, okay? But make sure you get that done. I'm going to go ahead and send you the instructions on how to do that. Okay, so let me send you instructions here. Okay, if you need any help with that, if you need help figuring out your username, your password, please email me. I'm happy to help you out with that, okay? So again, lab errors, please email me. Week 2 extra credit is Wednesday, Thursday. You have 2 more opportunities for that. And Star 360, get that done today. Both reading and math. You have to get both done. Awesome. So we are, again, starting a new unit. We're talking about unit number 2, which is forces and motion. So this week, we'll be taking a look at Newton's 3 laws of motion. We're going to also talk about acceleration and force. So that's where we are going today. Let's see our objective for today. So today we should specifically be able to understand the difference between 2 terms, speed and velocity. How many of you have ever heard of those terms before? Give me a smiley face. Speed and velocity. You've probably heard them as synonyms before, meaning that they mean the same thing in your brain, which is fine, right, in everyday life. Okay, Hope, it should be, that should be it, okay? Let me know if that doesn't work and I can figure it out for you, okay? Yeah, just email me if it still doesn't work. Okay, so you should understand the difference. Oh, sorry. So speed and velocity, oftentimes in everyday language, they mean the same thing to us. But in physics, they actually mean something a little bit different. So that's what we're going to go over today. We're also going to learn how to calculate velocity as well as acceleration, which is related to velocity. So we'll calculate and learn how acceleration affects velocity. So that's what we're talking about today, speed, velocity, and acceleration. Oh, sorry. Let me go ahead and send. Oh, sorry. So, Shoshana, it just looks like your computer is fritzing a little bit, isn't it? Well, I'll send you the ticket again anyways. Okay, so let's go ahead. We're going to start off by talking about velocity. So first off, motion describes how an object moves from one position or location to another. So motion is how you get from A to B. And we measure this in meters. Remember, we measure distance in meters in science, right? Meters is the unit that we use in science. We're not using feet or yards because those are not kind of the universally accepted units in the scientific world because they don't really make a lot of sense, right? Like meters does, okay? So speed, again, we talk a lot about speed. Speed is how fast an object changes position. So how fast it gets from A to B. Okay, so how fast it gets from A to B. Okay, hold on 1 second. 1 second, guys. Lost my pen. Baby stole a pen. Okay. Andre, I'm sorry. Can you just email me that? Because I don't have my pen to write it down. Because my baby stole my pen. Okay, can you email me? Thank you. All right, so sorry, speed is how fast we get from A to B, okay? Now, we measure this in distance per time. So distance divided by time, or the units that we could use, for example, are meters per second, right? Distance per time, meters per second, or what's this one? MPH. We actually use this one in our cars all the time. What does MPH stand for? Tell me in the chat box. This one we should be familiar with for sure if you've ever been in a car before. Yeah, miles per hour. So again, this is just saying that this is miles divided by hour. Now, the important thing about speed is think about your speedometer. When you go forwards at 30 meters per second or you go backwards at 30 meters per second, does that 30 meters per second become negative at any point? No, Cash, this is class. This is class. You always have class at 12 o'clock. You had support this morning. All right, tell me in the chat box if we go forward 30 meters per second or we go back 30 meters per second or miles per hour or whatever. Does your speedometer ever go negative? Does your speedometer ever go negative? Think about your car. Does it have negatives on it? Going forward 30 miles per hour, going backwards 30 miles per hour, do you ever have negatives? No, of course not, right? That would be really confusing if suddenly your speedometer started going negative. Okay, so for speed, the direction does not matter. We don't have positive or negative directions because speed just takes into account the speed alone. The direction, positive, negative, does not matter. It's 12:17 currently. Cash, we have class at 12 and I'm going to tutor you in the 1C lab at 2 o'clock. Okay, Los Angeles time. We're talking about Los Angeles time. Okay, now velocity, on the other hand, is both speed and direction. Okay? Guys, please don't talk about the attendance ticket. I always tell you what to write in your attendance ticket. You just need to wait. Please be patient. Focus on class, focus on learning, and then I will tell you when to do the attendance ticket, okay? So just don't freak out about it right now. We're just going to focus on actually learning, okay? Now, velocity, on the other hand, is a little bit different because velocity actually does care about direction. Take a look at this. Velocity is actually speed and direction together. So when we talk about velocity, we need to include direction. You could say 3 meters per second to the right, or you could actually even say positive 3 meters per second. Or you could say 3 meters per second to the left, or negative 3 meters per second. So velocity can absolutely have negatives, unlike speed, because speed does not care about direction. Give me a smiley face or a thumbs up from your smiley face menu if that makes sense. Everyone, smiley faces if that makes sense. Let me know. Again, speed, just speed. Velocity also has direction. Cool. Now for number 1 in your ticket, you need to fill in the 2 blanks. The first blank gets filled in with the word time. The second blank gets filled in with the word direction. Just like you see boxed here in red. You have 40 seconds to get that filled in. Green checks when you have number 1 saved in your ticket. Go, go, go. Yes, Misael, I just said. So the first blank is the word time. The second blank is the word direction, just like you see boxed on the whiteboard in red. So this is what we're filling in for number 1. I need a few more green checks. Again, make sure you spell those words correctly. Make sure you only put in what's in the red boxes. You don't need to put anything extra, just what's in the red boxes for the blanks. Waiting on a green check from Amir. Let's see here. Bradley, I know you just joined us. Get me that green check once you get it open, though. Waiting on a green check from Danny, David, Dusty, Dree, Dylan, Edwin. Let's see here. Mike, Nate, Razi, and Ricky. Green checks, please. Yep, I'll send it again. Here you go, Bradley. Awesome, everyone. Looking good. All right, let's keep on moving here. So now in order to calculate velocity, again, we talked about the fact that it's distance per time. So you need to know both your distance and your time. So the equation for velocity is just distance divided by time. It's a super easy equation. We're going to go ahead and work with it a little bit just so that we become familiar with it. You don't have to memorize anything. And I know math can be a little bit scary, but we're going to do it together. So it's going to feel like you really understand it because we're working on it together. Now you do need to have a calculator. So either grab your phone calculator. Where's my phone? Grab your phone calculator, or you can also Google calculator on your computer, and that'll also pull up a calculator, or your computer even has a calculator, but everybody needs a calculator of some sort, okay? Smiley faces if that makes sense. If you have a calculator ready, again, use either your phone, your computer, Google. Awesome. Okay, so here we go. In this example, we have a dog that walks to the right for 1.5 meters in 3.6 seconds. So we need to figure out how do we fill this in. So in the first blank, just like you see over here, we need to have the distance. So take a look up here. Which of these is the distance? 1.5 meters or 3.6 seconds? Tell me in the chat box, which of these is the distance? I need everybody participating. You're doing the work for yourself. You're not just relying on your classmates. You yourself are capable of doing this. Yeah, so the distance is 1.5 meters. So we're going to fill in here 1.5 meters, or M for meters. Now, in the second part, it says we need to have time, right? The second part, divide by time. So what would I fill in for time here? So this up here was distance. Now what do I fill in for time? What do I fill in for time? Excellent. I see an answer from Taylor, Andres, Stacy. Yes, yes, yes. We're going to fill in 3.6 seconds for time. Perfect. So 3.6 right here and S for seconds. And now we need to plug it into our calculator. So I'm going to go ahead and pull up a calculator right here very quickly. Okay, 1.5 divided by 3.6. So let me share this with you. All right, smiley faces, everyone, if you can see my calculator up here. Smiley faces, if you can all see that. Okay, so what did I say? It was 1.5 divided by 3.6. Okay, so you do 1.5 first, the division sign, and then 3.6. And what does that equal? Go ahead, use your calculators. Tell me, what are you getting? What are you getting? What number are you getting? 1.5 divided by 3.6. Go ahead, tell me in the chat box. I got an answer from Justin and Taylor. They are on top of it. Everybody else, use your phone, use your computer, calculator. Everybody, 1.5 and then divided by 3.6. Yes, perfect. Thank you, Andres. Thank you, Tariq. Good, good, good. Yes, I'm going to go ahead and press enter here. So you should be getting this super long number. So I'm going to round and I'm going to say 0.41. Should actually be rounded up to the number 2 because 6 is actually a big number. It's bigger than 5. So technically this would be 0.42. Smiley faces if you feel comfortable with that. Okay, so this is 0.42 if we round up in the hundredths place. Excellent. Okay, so let me go ahead and jump in here and I want to go ahead and put this here. So this is going to be 0.42 and our units, right, we had meters divided by seconds, so our units should be meters per second, m/s. Okay, thumbs up if you feel good about that. So 0.42 meters per second. Excellent. Okay, now specifically the 0.42 meters per second tells us that the dog is moving to the right. All right, because to the right is the positive direction. Now, what do you guys think would happen to our answer if you walk the same distance in the same time, but to the left? What do you think would happen to our answer if he actually walked to the left? Take a look at our number line here. What happens when we go to the left? Yeah, your answer actually becomes negative because he's actually going in the negative direction, right? So in this case, his velocity would actually be negative 0.42 meters per second. Smiley faces if that makes sense. Yes, awesome, Stacy, exactly. Negative 0.42 meters per second because he's going in the negative direction. Perfect. Okay, so let's go ahead and try this next example. Let's go ahead and set this up. So again, our equation is velocity equals distance divided by time. So take a look here. A car travels forward 13 meters in 2.7 seconds. Let's go ahead and set our equation up here. 13 meters, is that our distance or our time? Is 13 meters our distance or our time? Tell me in the chat box. D or T? D or T? Distance or time? Yes, this is going to be our distance. Perfect. What about 2.7 seconds? What is that? Seconds tells us that this is, yes, this is going to be our time. Exactly. So if I go ahead and I plug this in, right, velocity equals distance divided by time. So I start with our distance, which is 13 meters, divided by our time, which is 2.7 seconds. Okay, so distance divided by time. Go ahead, plug that into your calculator. Tell me, what answer are you getting? 13 divided by 2.7. What is our velocity for this car? Velocity equals what? Velocity equals what? 13 divided by 2.7. This with you up here? Yes, I'm getting lots of good answers here in the chat box. Okay, now what I want you guys to remember is that anytime we have numbers in physics, we also need to include the units. All right, otherwise your numbers are naked and very unhappy. So let's put some clothes on them. What units would I put for our velocity? Right, we had meters divided by seconds. So what does that make? Yes, don't have naked numbers. Put some clothes on them. So if we have meters divided by seconds, what is our units? Tell me in the chat box. What were those special units that I just showed you a little bit earlier? Meters divided by seconds. That gives me what kind of unit? No, not seconds. It actually gives me m/s. Okay, so, m/s. So try that out. Give me that number again, but this time put m/s next to it. Meters per second should go next to it. So everybody retype your number, but this time go ahead and put m-s next to it, meters per second. Get used to using your units, get used to putting clothes on your numbers. Yes, perfect. There we go. So our answer should be, you are correct, 4.81 meters per second. Very well done. Let me jump over here. So our answer here should be 4.81 meters per second. Okay, do you guys feel good with that? Do you guys feel like you can do this next one? Give me a thumbs up if you feel like you can work on this next one. Do it a little bit more independently. Okay, perfect. So I'll set you up first just to remember what distance and time is. So 42 meters, is that our distance or our time? Is 42 meters our distance or our time? Tell me in the chat box. Yes, this is our distance, which means that the 1.9 seconds would obviously then be our time. Okay, so remember, you're going to need to plug that into our equation. First, put the distance first, and then divide it by the time second. All right, go ahead. Tell me, what is the velocity? Please include units. Don't give me naked numbers. Please include these velocity units, meters per second. Meters per second. Go ahead, get me your answers in the chat box. All right, I got an answer from Andres. I see Tariq typing, Taylor typing, Israel typing. Get your answers in the chat box. Again, a bird is flying down 42 meters in 1.9 seconds. What is its velocity? Remember your units. I see Andres gave me units. Love it. I see Dree typing, Hope typing, Arrow typing. Awesome. Get your answers in the chat box. Again, do the distance first, divided by the time second. Awesome, Arrow. Thank you. I see yours. Everybody, make sure you're answering. You probably will get the same answer as someone else. Hopefully everyone's getting the same answer, but you should still type it just to get used to using that meters per second. Dree, Parker, make sure you're using meters per second, and to make sure that you're reinforcing your own learning, right? It's not helpful if someone else is learning, but you're not. Exactly. Awesome. So looks like we understood this, right? You should be plugging in 42 meters divided by 1.9 seconds, and what you should get is 22.12 meters per second. Excellent. Now, here's the thing. This is almost correct. Almost correct. There is actually one thing that we're missing. What I want you to keep in mind here is that the bird is actually flying downwards. So take a look over here. Is downwards the positive direction or the negative direction? Is going downwards the positive direction or the negative direction? Yes, so it's actually the negative direction. So let's fix our answers one more time. Go ahead, type your answer, but include the fact that it's going in the negative direction this time. Let's fix our answers here. Let's see what we get. Again, we're going downwards, so our velocity is actually negative. Awesome, Tariq is first in the box with that. Let's see who else is able to figure out what I'm talking about. Yes, our answer should be negative 22.12 meters per second. Excellent job. Go ahead, give me a green check if you feel good about that. Green check if you feel good about number 2 here. Okay, again, the calculation was wonderful. We just got to keep in mind that negative directions result in negative velocities. Perfect. Okay, looking good. Now, here's what I want you guys to think about. So here I have a tennis ball. Okay, so what would you like our tennis ball's name to be? He's got some fangs on it. I'm not really sure why. I think he's a vampire. But what should our tennis ball's name be? Jack, Steve, Jerry, Joe. Everybody has a different name. George? All right. Well, maybe I'll send out a survey and we can figure out what to name our class tennis ball here, because I do use this tennis ball quite a bit. So here's what I want you guys to think about. So I'm going to push this tennis ball with a small, medium, small, medium, and large force. And what I want you guys to notice is what happens to how it's... Oh, the Jack in the Box guy, gotcha. And we're going to figure out how does the velocity change based on the force that I apply. So let me go ahead. I'm going to drag this over here. Drag our webcam over here. All right, everyone. Can you see here? Smiley faces if you can see my webcam. See the ball here. Perfect. Okay, so here's my ball. I'm going to go ahead and push it with a small force. So small force. What happens with its velocity when I push it with a small force? What's happening? What kind of velocity are we getting? Small, medium, large velocity. Change in velocity with a small push. Yeah, definitely a small change in velocity. Okay, yeah, it's super slow, super slow. What about if I start pushing it a little bit harder? So a medium push. Now what is its velocity like? Is it slower? Is it faster? What's happening when I do a medium? Yeah, it picks up a little bit. Yeah, it gets faster for sure. Yes. Sorry. Sorry, David. I can go back after class, okay? Or it'll be in the recording too. All right. Now let's go ahead and do a large force. Here we go. Large force. What happens to its speed then? Oh, I think I almost lost it. What happens to it when I do a large force? Way faster, right? It just rolls across the screen so quickly. Can't even see it. So here's what I want you guys to think about. When we have larger forces, does the velocity become faster or slower? Larger forces, do our velocities become faster or slower? Yeah, they become much, much faster. So larger forces create much bigger changes in velocity. So let me get this here. They create bigger changes in velocity. Give me a smiley face if that makes sense. Okay, we're going to talk about this in just a moment because this is our next topic, which is acceleration. So larger forces create bigger changes in velocity. Okay, excellent. So now we can actually jump in and talk about acceleration. So a force, what you just saw, is either a push or a pull. So in our example, I was using pushes as my force. Now forces accelerate objects, which I just talked about. This idea that a big force causes a big change in velocity, that is acceleration. So acceleration is any change in velocity. Okay, so this ball, okay, take a look once more at our ball. What is my ball currently doing? There's no forces being applied. What is my ball currently doing here? It's doing nothing, right? So this ball is never going to move unless I start applying a force. Once I apply a force, then the velocity changes, right? It speeds up, it starts moving. Okay, it's taking a nap. Yes, it's daytime, so our vampire tennis ball is taking a nap. Okay, so acceleration is any change in velocity. This means you could be speeding up, getting faster. It means you could be slowing down, getting slower. It could even mean that you're changing directions because velocity, remember, includes direction. So if you change direction, even if your speed is still the same, any change in direction is still going to be a change in velocity. Smiley faces if that makes sense. So acceleration is any change. Get faster, get slower, change directions. Perfect. Okay, so again, acceleration is defined as the change of velocity of an object, the rate of change of velocity of an object. Now, if we have positive acceleration, this means that we are increasing our velocity. We are positively changing our velocity. So take a look over here. Which of these do you think are getting faster? Okay, there's actually a couple of these. So we've got, sorry, I'll label these. So we've got one. Which of these four show a positive acceleration where we are starting out slow and getting faster? Positive acceleration means our second velocity is faster, increasing velocity. Tell me in the chat box. Yes, so there's actually two of them, as Andres figured out. Israel, Taylor, you each got one of them. Everybody in the chat box participate. Yes, so both of these are actually showing a positive acceleration. So if you start off at rest, like our tennis ball started, it was not moving, and then you start moving, that is positive acceleration because you're starting motion and you're getting faster. So this car is going from 0 to 4 meters per second. It got faster. Smiley faces if that makes sense. This is a bigger ending velocity. Right, we've got a bigger ending velocity. Perfect. Now, same thing with number two. Number two, we can see that this guy's already moving, but then he presses on the gas and he accelerates even faster to go even faster. 9 meters per second. He started at 7, now he's at 9, which means he got faster, and that was a positive acceleration. Positive acceleration. Now, this one should make a lot of sense to us because we actually talk about acceleration in the positive all of the time. Okay, so you say accelerate, go faster, right? Now, the other thing is, though, you can actually have negative acceleration, which a lot of times if we're talking about cars, we actually call this deceleration. Okay, so negative acceleration still means that our velocity is changing, but it's changing for the negative. It's changing to become slower. So take a look once more at our examples here. All right, 1, 2, 3, and 4. Which of these show negative acceleration where we're actually getting slower? Which of these show negative acceleration where we're getting slower? Got an answer from Israel, from Dree, from Tony. Thank you. Yes, number 3 and 4 actually show negative acceleration. So number 3 shows that we're getting slower, right? So we start at 6 meters per second, we put on the brakes, and we start slowing down to 3 meters per second, maybe because we saw a police officer, right? Although we should always be driving safely. Now, the other option, right, is stopping motion. So let's say that we're driving and then we want to completely stop. We press on the brakes really hard, going down to 0 meters per second. That is also a negative acceleration. Give me a thumbs up if that makes sense. Negative is a little bit hard to conceptualize. It just means you're slowing down, okay? So even though it says the word accelerate, the fact that I'm saying negative means you're actually slowing down. Perfect. Now, here's the craziest part. You can actually have 0 acceleration. So 0 acceleration means that there's no change in velocity. So either, there are 2 options. Either you are staying at rest forever, right? So take a look at our tennis ball here. This tennis ball has 0 acceleration because it's at rest and staying at rest. Okay, that one's pretty easy to think about. But the harder one to think about is you can actually be in motion and still have 0 acceleration. So imagine you're driving at 30 miles per hour and you're just staying driving at 30 miles per hour the entire way. Then you have 0 acceleration because you never get faster, you never slow down. Okay, you maintain the same exact motion, the same speed, the same direction. So you never feel your body go whoosh or whoosh or whoosh or whoosh. Basically. Okay, if there's no acceleration, your body never feels that change in the car. Smiley faces if that makes sense. You can actually be moving. You can actually be moving and not be accelerating. Okay, so acceleration just means there's no change in velocity. It's kind of mind-blowing to think about. Yes, exactly, Tariq. That's a good way to think about it. Love it. All right, go ahead and match these up really quick, please. Go ahead, use these, match these up. Stopping motion, getting faster, maintaining motion, starting, getting slower, staying at rest. Is that going to be positive, 0, or negative acceleration? Match those up very quickly. Let's go, let's go. Remember, use thin lines, and please don't use the color red, because that's what I'm going to use. I know, exactly, Tariq. So in reality, we are actually hurtling through space, you and I, right? We're actually moving very quickly at all times because we're rotating with the Earth. It just doesn't feel like it because the Earth never changes its velocity. So the Earth never gets faster or slower, and so we never feel that jerk, right? So you've just always been moving super, super fast your entire life. You're basically the Flash. Awesome, everyone. Let me go ahead and pause your tools here. This looks beautiful. Let's make sure it's all correct, though. Right, looks like we have lots of agreement, but let's see if we all agreed correctly. So I'm going to shrink these down. Get your mouses ready. This is the answer to number 2 in your ticket. Okay, so stopping motion, yes, that's going to be negative acceleration because you slow down to 0. Getting slower in general is negative acceleration. Perfect. Looking good. Next one. Getting faster will be positive acceleration. That one makes a lot of sense to us. We do that all the time. Same thing with starting motion, right? Going from 0 to a velocity is going to be positive. And then last but not least, let me grab a different color here. Maintaining motion is actually 0 acceleration. Again, you can be moving, but as long as your movement doesn't change, you have no acceleration. As long as you don't feel your body jerk in any direction, you're actually 0 acceleration. And same thing, obviously, with staying at rest. This is the answer to number 2. Give me a green check when you have number 2 saved. I'm going to give everyone 40 seconds to work on that. Go, go, go. Bradley, when the recording gets uploaded at 2 o'clock, you can go ahead and see the answers then. Just make sure you save the password so that you can still log into your attendance ticket later. Everybody else, please don't make sure, I've never said this, but please don't put any answers in the chat box just because I want to make sure everybody actually sees the answers for themselves. Thank you. All right, I do need green checks for number 2, waiting on Amanda, Amir, Andrea. Let's see here, Ashton, Colby, David, Dusty, Dree, Dylan, Edwin, Isaiah, Jaime, Cash, Kevin, Mel, Misael, looking good. Tariq, you're like, I'm moving so quickly. This is exciting. Cool, everybody. Okay, so the last thing I need to talk about is when we calculate acceleration, acceleration is actually the change in velocity divided by time. So because of this, the units for acceleration are very similar to velocity, but with an extra second because there's an extra amount of time that we're dividing by, okay? So this is actually meters divided by seconds squared. That's the units for acceleration. Give me a smiley face if that makes sense. Come on, Tariq. Math is not bad at all. Math is not bad at all. Okay? So again, units for acceleration are meters per second squared. Sorry, we aren't actually going to get to do this calculation right here. We don't have enough time. But let's go ahead and do our last question. We should easily be able to finish this one up. And then I will give you the last word for today. So go ahead, match these up very quickly, and then we are going to wrap up since we're almost out of time. Let's go. Work quickly so that we can finish class up. I appreciate all of your hard work and effort. Looking good. Gonna pause in 5 seconds. 1, thank you. I know I cut you off a little bit, but I want to make sure we finish everything. So yes, a force is a push or a pull, absolutely. Distance is the length an object moves in meters. Velocity is speed with direction. Remember, with direction. And acceleration is the rate of change in velocity, either getting faster or slower. This is number 3 in your ticket. Give me a green check when you have that saved. I'm gonna give you 30 seconds. And then I'll give you the last word and we'll wrap up. Sorry, I know I'm like down to the last few moments. Go quickly. All right, waiting on Amanda, Amir, Andrea, Tony, Ashton, David, Dusty, Dree, Dylan, Edwin, Hope, Ireland, Jaime, Cash, Kevin, Ricky, green checks for number 3. Looking good. All right, everyone, I do need to finish up. So here was our objective for today. I'm going to send you your quiz. Remember, all of the answers you actually just did in your attendance ticket are actually the same answers as in your quiz, right? They're not in the same order, obviously, but if you look at your ticket and look at your quiz, you should be able to have everything you need to get 100% on your quiz. So you're going to go ahead, have them open side by side, then submit them at the same time. Smiley faces if that makes sense. Do it right now. It's super fast. It's only 6 questions. You got this. I believe in you. Awesome. Here's your last word. Thank you so much, everyone. Hope you have a wonderful day. If you missed anything, it will be in the recording uploaded at 2 o'clock. All right, Michael? So just check the recording at 2 o'clock and you just save your password, though. Always save your password. You're welcome. Bye, everyone. Have a wonderful day. Thank you so much.